Okay, so let's look at the limit, another example. As x is approaching 0, the absolute value of x all over x. So recall that an absolute value function, it depends on what value you're plugging in for x, depends on what value you're getting back. And so an absolute value function can be rewritten as a piecewise function. So the absolute value of x, this is equal to, well, if our value of x is greater than or equal to 0, so if you plug in a positive number in there for x, right, you're just going to get back x itself. Same number, absolute value of a positive is that positive number. If we plug in numbers less than 0, though, so if I plug in -1, the absolute value of -1, I have to take the opposite sign of that. So I have to look at, really, the result is negative of x. Well, so we need to kind of break this down. What happens if we're dividing by x in this case? So let's look at the absolute value of x all over x. There's two different case scenarios. So if x is greater than, let's just say greater than 0 here, because we can't have 0 in the denominator. And the x is greater than 0, so if I plug in a positive number, well, the absolute value of the top is still that positive number all over that positive number. The same number. So the same number over the same number other than 0 is 1. So if x is greater than 0, we're always going to get back the y value of 1. If x is smaller than 0, though, so if I plug in a negative number into that absolute value, it's positive. It's the negative, that number, all over the same number but opposite sign. And so positive or negative is negative. So a over negative a is -1. So notice that the limit as x goes to 0 here, if we look at, we have to show left and right are the same values. So if we're looking at zeros coming in on the left-hand side, these are where I'm saying my values of x are less than 0. If x is less than 0, it tells me I'm using my second function. So that would be saying I'm plugging it into 1. Well, there's no really x in there for 1, right? Or negative on 1, I'm sorry. So limit as x goes to a number, any number of a constant is that constant, which is -1. Where if I look at the limit as x is approaching 0 on the right of this function, that means I'm choosing values of x which are greater than 0. Numbers x are greater than 0. This tells me I'm going to plug it into this function, which is just 1. So limit as x approaches 0 on the right of 1 is equal to 1. So here's a case now that we can say that limit doesn't exist because these are not the same values. So I have the limit as x approaches 0, and the absolute value of x all over x does not exist. Okay, so on an exam, I wouldn't want you just to say, okay, well, the limit is the absolute value of x over x doesn't exist. You would have to show me why it doesn't exist. And so you'd have to go through and give me the explanation of why you came up that it didn't exist. And in this case, because the left and the right-hand side are not the same.